Thank you. My name is Simo Siiriä. I'm from the Finnish Meteorological Institute. I'd like to use this moment to talk a bit of extension of Argo operations in the polar regions and what our project Euro-Argo Rise does to this end. First, a few words about the Argo project itself. As most of you know, it is an international project measuring salinity and temperature within the oceans using automatic profiling floats, the ARC floats. All the data for this project is really available for anybody from the webpage, for example here. At the moment there is more than 4,000 Argo floats measuring all the times. Here each yellow dot shows one profile measured within 10 days. So it seems that we have actually pretty good coverage on the oceans. However, when we look the same thing from the polar regions, Antarctica and especially the Arctica, the situation isn't that good. The main reason for this is ice, mainly. When we think how the Argo float works, when it's deployed, it floats in a certain depth, usually a few hundred meters, then goes down to the profiling depth, 2,000 meters usually, goes up, makes the measurement, then on the surface gets GPS coordinates, sends the data to us, goes back down, repeats this once in a 10 day as long as its batteries last. And usually this works pretty well, we get good data sets. However, when there is ice present, the main problem is that if the float during the ascension collides with the ice, there is a high risk that the antenna is broken or the sensors are broken, or both. In general, collision with the ice results in loss of the instrument and end of data. So that's what to be avoided. However, this can be overcome to some degree. A main way to do this is applying an ice sensing algorithm, ISA for short. These are typically applied so that during the ascension, the temperature is measured, and if it is less than some given threshold, the ascension is stopped, the float goes back down, and tries again in the next iteration and continues this as long as it gets to the open sea. In principle, this is simple. The problem is that the trigger temperature that works for different areas vary quite a lot. I've gathered here a few samples which we have found to be working in some earlier researches. For example, the temperature trigger varies from -1 to -1.7 in these samples. You want to pick it carefully because if you are too careful, you lose lots of data. Then again, if you are too daring, you lose the float and all the data. So it's actually quite tricky to get it right. Many have got it right, but the problem is that the information of how to do it is kind of scattered in different operators. And this is where our project comes in play. One thing which we want to do is gather up all the known facts, how the ISA algorithm has been working on different areas, and have our own deployments and further develop what kind of algorithms work and preserve most of the data for us. For this end, we are gathering up a best practices document where we try to get all this information in one place. Here's one sample of one of our experiments in the Barents Sea. This lasted for 2 years, temperatures and salinities. You can see from the lack of the upper layers that it's lasted for 2 years successfully. The dataset is good, it covers the whole 2 years, give or take the upper layers. And of course, if you look at the trajectory, you can see that there is the winter times are interpolated, so we don't really know that well where it has been during those times. However, we do get the data. Without the ISA algorithms or failed ISA algorithm, we would have got just the start of this whole series. Anyway, all this works for our project. We have the project page and GitHub, and so you can follow the documents, deliverables for the best practices, all the software we have developed for data analysis, quality control, estimating of the locations, and so on is in our GitHub. If you find this interesting, please do keep eye on this. If you have something to add which we could use, please do contact us. And if you find this interesting, contact us. In any case, thank you for your attention.